All right, guys. So good evening once again. So we are on another session. And so we are continuing from where we left off yesterday. We started off by looking, well, not started, but we were looking at functions and we had reached up to inverse function. So I'm just going to start back at inverse function and recap what you would have learned about inverse functions, right? So as we were saying, or as I was saying, if you have a function, and remember, a function is a relation, but it's a special kind of relation. So it means that you will have ordered pairs, and ordered pairs in this case is just simply the coordinates. And we know that in the order in which the coordinates come, it would be the x coordinate first, then the y coordinate second. So all of these numbers in brackets indicating the ordered pair of coordinates. All right. Now for function, we generally call the x element, we call them the set of elements in the domain. And the y elements, we generally call those the set of elements in the range. Now we are saying that if we have an ordered pair such that we have a function f, and if we are to get an inverse function for f, then that inverse function would take the output of f, meaning it would take the range value of f, and it would input those values, and then now you would get back an output of the x values are the domain values of f. So in other words, we plug in the y values in the inverse function, and we'll get back the x values that we would have in the original function. All right. So the inverse function really is a function that will take the end result of what you calculate, plug them in, and give you back the values that you calculate, or the x values that you calculate. So an inverse function for f would be a function that interchange the domain value with the range. Now in f, you notice that the domain values would be 1, 2, 3, 4, and the range would be 3. Let me just indicate. So these are the domain values, 1, 2, 3, 4. And the other values, which is the second elements, would be the range values, or the values of the range. Now, when you have an inverse function of f, if you plug in all of these range values, what will happen is that the ordered pair would just interchange. So in other words, where you would have 3, it would interchange with the 1, right? And where you would have 2, it would be interchanged with the 6. And where you have 3, you would interchange it with 4. And where you have 4, you would interchange it with 12. So that would be the effects of the inverse function. And so if you look at this function g, you will clearly see the interchange. So what was the y value, or what the y values were, or the domain values were, they now become the x values, are what we call the domain values in the inverse function. So g here would be the inverse function of f, right? So this function takes the y values of f, plug them in, and get back the x values of f. All right, so that's what an inverse function do. All right, now to be a little bit more formal with the definition for an inverse function, in order to show that G is an inverse function to F, we're generally not going to change the letter. We just use G here just to somewhat make a distinction. But when we are writing the inverse function of F, we write it as F to the minus 1. So instead of using the letter G to denote inverse, we would use F to the minus 1. Is that clear, guys? All right. So with that said, moving on. So F and G are inverse relations, right? And here now, if we have G, G is the inverse of F, it is denoted by F to the minus 1. So therefore, G is equal F to the minus 1. Also, if you should interchange the inverse of, in other words, if you're now looking at the inverse of G, then that would give you the function F. So function F is the G inverse. All right, so a definition for the inverse here. So F inverse, the inverse of the function, or F to the minus 1, the inverse of the relation of F is obtained by interchanging the components of each ordered pair, as we would have looked at already. All right. Now here we look at this question, and this question was asking you, now we are to find the inverse. Now remember, we say that for functions, we write them in two different ways. So you can write it F with the colon, X maps on to 3x plus 1. So writing it in this symbolic form is really describing the function. All right, so you can describe a function by writing it in this way, or you can describe it by writing it in this way. Now, so both ways are used when we're doing functions. So whichever way it is written, you should be able to identify that you're dealing with functions. All right. So now, if we are to find the inverse of this function, and I'm working with the notation on the right, so if we are to find the inverse of this function, there are some steps that we have to go through. Anybody remember the first step that you go through? What is the first step?
Sir, first step we have fx equal to 3x plus 1, and then you replace you put, instead of using fx, you use y equal to 3x plus 1, and then anywhere you see x, you put y, and where y is, you put x. Interchange.
Well, the first step is just to replace the fx with y. That's the first
Yes,
step.
sir.
All right, so the second step now would be to do what?
Where y is, sir, you replace it with x, and where x is, you replace it with y.
All right, so you actually just switch the y with the x. So we would put the x where the y is, and we put the y where the x was. So get that. All right. Now, after we have made that interchange, then our next step is to do what? Let me find out from somebody else. Dorothy, what is our next step?
So we're gonna transpose the formula, making y the subject.
Good. All right. So in order to do that, remember now, we treat it like how we're solving equation. So we're going to keep the y term on one side of the equation and everything else on the other side. So here we can keep the y on the right-hand side and bring everything to the left-hand side. Now, the reason why we would want to keep the y on the right-hand side, because it is already positive on this side, and we really don't want to make it into a negative subject. So if we bring this one over here on the left-hand side, now we would have x minus 1 equal to 3y. And our next step now is to get rid of the 3 from beside the y. So the 3 is multiplying the y. We have to now divide both sides. So we always do the opposite operation of what that number is doing. So the y, 3 is multiplying the y, so we divide by 3. So we divide both sides by 3. And so the right-hand side, the 3's cancel. And so we are left to it. On the left-hand side, we have x minus 1 over 3. And that would be equal to y. Now we are accustomed to having our y on the left-hand side of our equation as a subject. So in order to get it in that form, we just flip around the equation. So what is on the left, we bring it on the right, and what is on the right, we bring it on the left. So we put the y on the left and put x minus 1 over 3 on the right. All right. Now, once you have a denominator, the entire expression over a denominator, remember that that denominator, you put 1 over it. So you would have 1 over 3, which is a third. And then you put the numerator in brackets. And it gives you the same thing as what you would have before. All right, but this is just a little bit more elegant in terms of presenting the information. So now that we have this in the simplest form, we now want to replace now. So in this step, we're going to replace the y with the inverse notation of f of x. And the inverse notation of f of x would be f to the minus 1 of x is equal to 1/3 bracket x minus 1. All right, so everybody is clear on that? Raise your hand if you're good with that. All right, so with that said, then what the main thing that you're supposed to do here is to become familiar with the steps. As I said, memorize what you do in each of the steps. So there are the 4 steps, and the final step we write the inverse function. All right. Here we had started looking at this question from yesterday. We were asked to find f of 3, that's part A, and we did that. And you were told that for part B, C, and D, you should try that at home. Did anyone get a chance to try B, C, and D? All right, so part B is asking you. All right, Mr. Lamar had done A for us yesterday. And A would be simply to substitute 3 where the x is
4 over 5.
So we will have 3 times bracket 3 minus 5 over 3 plus 2. And so we will get 4 over 5. All right, so that was the first part. All right, now the second part says you have to write down the real number for which cannot be in the domain. Now remember, the domain has to be an x value. So based on this function, which x value cannot be in the domain? That's what this is saying. Anybody can guess? All right, so in other words, what it is asking for, which value would make this fraction meaningless or undefined? Which value of x would make the fraction undefined? Anybody remember when a fraction is undefined, what it means? Guys, nobody remember that?
No, sir.
Okay. Suppose I have a fraction of 3 over 0. Is that possible?
No, sir.
No. So it means that if the denominator is 0, then the function or the fraction will be undefined. So which value of x would make the denominator of this function become 0? Now, if you take out x and put in a number, which number you could put here to make the denominator 0?
-2, sir.
Exactly, -2. So if x is -2, the denominator will become 0. And so we would say that it would make this function undefined. So because of that, we cannot put -2 in the domain because -2 going to make this function undefined. So that's why we don't want it in the domain. All right, so in answering this question, one other thing that you want to say is that the denominator, which is x plus 2, cannot be equal to 0. Because if it is equal to 0, it will be undefined. And if x minus 2 cannot be equal to 0, and if we treat this as an equation and solve it, then we are saying that x cannot be equal to, now what we would do with the 2, we bring it across and change the sign, right? Oops. So x cannot be equal to -2. And so that would be the answer. So therefore, x cannot be in the domain. Sorry, therefore -2 cannot be in the domain. All right, guys. As you know, I'm no expert in writing with this device. All right, so it cannot be in the domain. All right, so that would solve part 2. Now, part 3 now asks that you find the expression or find the inverse function. That's what this is asking you for. Find f of x inverse. Now I'm going to give you a chance to try that following the steps that we had just looked at before and see whether or not you'll be able to arrive at your answer. So try finding the inverse. I'll give you about 3 minutes to try and find it, and then we will do it together. All right, guys, so you may begin. Your 5 minutes starts now. All right, did anyone come up with an answer? Anybody? All right, let us go through it together.
Sorry, I get the answer.
All right, all right. I'm just going to walk through it for the benefit of everybody, Miss Dorothy. All right. All right, so here we have f of x equal to 3x minus 5. So f of x equal to 3x minus 5 over x plus 2. All right, so what we want to do next, if we are following the steps, we would replace f of x with y. So therefore we would have y, or if you want to say, if you want to use this symbol, which means implies. So this implies that y is equal to 3x minus 5 over x plus 2. All right, now what would be the next step? Anybody? Ms. Waysam, what would be the next step?
Sir, with interchange, where y is, you put x, and where x is, you put y.
All right, so interchanging, we would get
X equal
so we would get x equal
3y
2y
minus 5
minus 5
over y plus 2.
over y plus 2. All right. So our next step now would be to do what?
Make y the subject, sir.
All right. So if we are going to make y the subject here, it means that we will have to rearrange this equation. But what you notice is that we have a y in the numerator on the right-hand side and a y in the denominator. Now, we cannot make y the subject unless we get y to be singular, right? So in other words, we have to somehow get those y's together, group them together, factorize it so that the y can become 1, and then now we make y the subject. So first we want to get rid of the denominator. And as I mentioned before, you treat it like how you're solving equations, right? And so if you consider doing like a cross multiplication, what is in the denominator on the right side? You can do a cross multiply with the x, and then that would, remember, if you write this as x over 1, because x can be written as x over 1, then the other side would take 1 times the numerator. So that would give you a cross multiplication. So remember now, this is an expression, x plus 2 is an expression. So we have to keep the expression in brackets. So we have y plus 2 in brackets. And then now that would be equal to 1 times 3y minus 5, which is just simply 3y minus 5. All right, so how can we get these x together? So for the left-hand side, we want to expand the bracket, remove the x from the y from the bracket by multiplying it out by x. So we are going to get x times y, give you xy, plus x times 2 will give you 2x. And that would be equal to so that would be equal to 3y minus 5. Now what we want to do now is group the y's on one side of the equation, and everything else would be on the other side. So it means that this 2x if we are to group the y, I would say try to group the y on the side where you can make them positive. Or if you, it doesn't really matter, but you have to be very flexible when you're doing this. All right, let's say that we want to bring over this 2x to the right-hand side, and then bring over this 3y to the left-hand side. Then what we would get on the left-hand side is xy minus 3y would be equal to, now we will have negative 2x minus 5. All right, what we are really concerned with is making the y's into a singular y. So if we factorize this left-hand side by y, we would get y as the common factor. So we take out y, and then we would factorize by y. So we would say y into xy will give you x, y into minus 3y will give you minus 3, and that would equal to minus 2x so that would be minus 2x minus 5. Now, what we want to do now is to get rid of this bracket from beside the y. So we'd have to divide both sides by what is in the bracket. So we'd have to divide this side by x minus 3. And we also divide this side by x minus 3. And so on the left-hand side, the x minus 3 would cancel out. And so you're left with y equal to minus 2x minus 5 over x minus 3. So therefore, f inverse of x would be equal to minus 2x minus 5 over x minus 3. All right, everybody is good with that? Is that clear? Is that clear, guys? Raise your hand if you're okay with the process. All right, now, as you notice, when you're dealing with questions like this, you have to apply what you know from equations, right? So it just means that you'll have to practice a little bit with these. All right, now that would have covered part C. Now we only have part B remaining. So I'm just going to ask you to quickly calculate the F inverse of 2, and that would be part B. So you're going to do that. And then now raise your hand and give me your answer when you're finished. All right, guys? All right, so give you another 3 minutes to do this. Say 3 minutes can start now.